In this lesson, we're going to look at the form of writing linear equations called point-slope. Now, point-slope is much more versatile than some of the other forms, but is a little less common, and people find minor issues with it that make it difficult. In short, point-slope form equations are those that take on the appearance y minus y1 equals m times x minus x1, where x1 and y1 are a point on the line and the slope is m. Now, a small variation of this that is seen quite often in math also is the form y equals a times x minus h plus k, where h and k represent some point on the line, and a is the slope, or more generally called the vertical stretch factor. So we can go through and use any point that we know lies on the line and the rate of change in order to write these equations. And just as a quick reminder, our rate of change equation slope is m equals delta y, meaning change of y, divided by delta x, or change of x. So that's y2 minus y1 divided by x2 minus x1. So we can calculate our slope and then use any point. For instance, in this first setup that is given right here, we have m, our slope is 2/3, and we know it passes through the point 6, negative 1. So if I start with my general equation, y minus y1 equals m times x minus x1, and then simply substitute in values. I know my m is 2/3, and x will be here, y will be here. I need to subtract my x portion of my line, and that point is 6, so I have x minus 6 in the parentheses. And then I have y minus the y point, part of the point, and that's negative 1. So I'd have minus a negative 1. If I simplify this, I get y plus 1 equals 2/3 of x minus 6. How can we do that with this other? M equals negative 1, and it passes through the point negative 2, 7. So again, starting with my basic equation, y minus y1 equals m times x minus x1. And this time my y1, or my m, is negative 1. So I have equals a negative 1 times. My x goes in there, my y goes in there. I'm going to subtract the x part of the coordinate, which is a negative 2. Subtract the y part of the coordinate, which is 7. Simplifying this, I get y minus 7 equals a negative 1 times x plus 2. So if we go back and look at information, the point 6(1) or 6 negative 1 sometimes is hard to see, but the question is, what does it take to make inside of this grouping set 0? That would be for x to be a positive 6. What does it take to make the other side of the equal sign also equal 0? And that would be y to be a negative 1. So that helps us locate our values. So this works if we have the slope and a point already given to us, but what happens if we're just given a pair of points? Let's take a look at the process for that. So for each set of 2 points, we're going to write the equation of the line that passes through them in both point-slope form and slope-intercept. So we'll get a little bit of comparison here of how the difference is in writing these equations. First thing we have to do, though, is we're going to have to find a slope. So slope equals change of y divided by change of x. So how does the y change if I go from negative 2 to positive 4? And the answer is it adds 6. Next, how does the x's change if I go from 4 to 8? The answer is it adds 4. Now if I simplify this fraction, positive 6 divided by positive 4, I get 3/2. Next, I take my general equation, y minus y1 equals m times x minus x1. And I substitute in values. Now my m is my slope, so I get 3/2. X minus, and on the other side my equal sign, y minus. Now I can use any point that I know lies along this line. So either 4, -2 can act as my x and y, or 8, 4 can act as my x and y. Since I like working with positive numbers better, I'm going to use 8, 4. So inside of the parentheses I get x minus 8, and then y minus 4. So this is the point-slope form of the equation. In order to get slope-intercept, I'm going to have to solve this for y and simplify. So my first step, y minus 4 equals, I have to distribute my 3/2. I get 3/2 x. 3/2 times a -8 is a -12. Then in order to get y by itself, I add 4 to each side. Y equals 3/2 x minus 8. So I now have my point-slope equation, and I have my slope-intercept equation. The point-slope was much easier because I didn't have to have any one specific point. Any point on the function will work. So our next one, g of 1 equals 4 and g of 3 equals 10. Remember, what's in the parentheses when we have function notation is our x value. So what would be my run from 1 to 3? The answer is 2. What is my rise going from 4 to 10? And the answer there is 6. So my slope will equal 6 divided by 2. And if I run that, I get a slope of 3. Now, taking my general equation, y minus y1 equals m times x minus x1. As I go to substitute in items here, my slope is 3. Then, as I use points, I can use, of course, either point. So I'm going to choose to use 1, 4, simply because the numbers are smaller. So I have x minus 1 in parentheses and y minus 4 on the other side. This is point-slope. Now in order to get slope-intercept, again I'm going to distribute. So y minus 4 equals 3x minus 3. Adding 4 to both sides, I get y equals 3x plus 1. So again, I have point-slope and slope-intercept. The point-slope quicker to get to because I can use any point. Now what would this look like in terms of applying to items in the real world? An internet service provider charges a one-time installation fee and a monthly rate for service. The table shows the total money spent, y, after X months with this company. Write an equation to model the data. Then what is the monthly fee and what is the install charge? So what I need to do is begin by finding my slope. And slope is change of y divided by change of x. For any two entries on this table, and we'll take the top two, my change of y would be calculated as 302 minus 176, and my change of x would be 6 months minus 3 months. So as I go through and compute this, I get my total change of y as being 126, and my total change of x as being 3. As I divide those, 126 divided by 3, I get a total slope value of 42. So now, picking any point, again, smaller ones work nicer for me, I have y minus y1 equals m times x minus x1. Using the first point, I have y minus 176 equals 42 times x minus 3. Now going through and looking at this equation, my slope is my rate of change. That's going to be my monthly fee. So on the side, monthly fee comes out to be $42. But in point slope form, I can't see what my basic install charge is. To get this, I will have to convert it over to a slope intercept equation. So carrying this through, y minus 176 equals 42x minus 126. Solving for y, I get y equals 42x. And then if I add the 176 to both sides, I get a plus 50. That is my y-intercept. So that's going to be my set installation fee at $50. So we can use the information to help build models for real-life situations. And then as a person on a budget, which all people are to some extent, you can go through and figure out what your expenses will be over different periods of time for different items that you have to purchase or choose to purchase. So point slope equation, can use any point, just need the slope and 1 point on the line, and we'll be able to work with that. So study up, make sure you have good notes, and get ready to use this stuff.